So in the previous question, we wrote the KSP expressions for both of these things. For this one, we said that the KSP is equal to the concentration of Pb2 plus concentration of I minus squared. And for this one, we said that the KSP is equal to the concentration Ag plus and the concentration of Cl minus. In this question, we're actually given the KSPs, and it asks for the molar solubility. So we need to determine the molarity, essentially, of each of these compounds when you try to dissolve them in water. And to do this, we're going to use an ice table and the KSP expression. So when you first try to dissolve this in water, the initial concentration of both of these things is X. In this case, we're going to gain X. In the case of I minus, we're actually going to gain 2X. At equilibrium, we're going to have X of this and 2X of this. So the KSP, which now we know, is 1.43 times 10 to the minus 8 equals X times 2X squared, because I minus is squared. When you do the 2x squared, you get 4x squared. And at the end of the day, what you find is that 4x cubed equals 1.43 times 10 to the minus 8. Again, that's because 2x all squared is 4x squared, and you multiply by another x, you get 4x cubed. Divide both sides by 4, and you get that x cubed is equal to 3.58 times 10 to the minus 9, and then take the cube root of both sides, and you find that X is equal to 0.00153 molar. Note that there's one PbI2 for every one Pb, so this X is also equal to the molar solubility of this, so the molar solubility is 0.0153 molar. The AgCl case is arguably slightly easier because you don't have this 4x cubed stuff, okay? So in this case, the Ags are initially, and the Cl minus are initially 0. We gain X, at equilibrium we have X. So in this case, the KSP, the 1.62 times 10 to the minus 10, equals X times X, or X squared equals 1.62 times 10 to the minus 10. Take the square root. X is equal to 1.27 times 10 to the minus 5 molar. So these are the values of the molar solubility of each of these compounds.